Good day everyone. Today we are going to discuss about mean absolute deviation. Mean absolute deviation for ungrouped data. The average deviation measures the extent by which each individual value in a distribution deviates from the mean of that distribution. As a measure of variability, the average deviation is considered more important or appropriate than the quartile deviation because it takes into account all the individual values of the distribution. So we have the formula for the mean absolute deviation. Formula for sample. So we have MAD, which stands for mean absolute deviation. So MAD is equal to the summation of the absolute value x minus mean over n. So MAD stands for mean absolute deviation. X stands for the individual value. X bar stands for the sample mean, and the small letter n stands for the total number of items or observation. We also have the formula for population. So we have MAD, which stands for mean absolute deviation. So MAD is equal to the summation of absolute value of x minus mean over n. So x stands for the individual value. Symbol mu stands for the population mean. Capital letter N stands for the total number of items or observation. So, what is the difference between the population and sample? Population is the entire group that you want to draw conclusions about. Sample is the specific group that you will collect data from. In statistics, when we say population, it does not always talk about people. Let's say, for example, the focus of your research is about bacteria. So, your population is bacteria, not the number of people. Okay, so what's the difference between these two? For example, you want to study about the blood type of the students in MNHS Maine. So, your population is the students, the entire students of the school. While sample, you will get the portion or the only portion of the population of the students. For example, our population in MNHS Maine is 1,000 students. So when you get the sample, you will only collect the portion of that 1,000. So for example, you will just get the 30 students from section 1. Okay, 30 students from section 1. So the size of the sample is always less than the total size of the population. So that is the difference between the two. For our example, we will use the formula for sample. Okay? So find the mean average deviation for the following scores. We have 22, 24, 26, 28, 30, and 32. So as you can see, we have created a table. So the first column, we put all the scores. The second column, scores deviation from mean. And the third column will be the absolute deviation. So before we solve for the mean absolute deviation, we have to get first the mean. So in order to get the mean, get the sum of the scores, which is 162. Then our formula for the mean, this is ungrouped data. So the mean is equal to the summation of x over n. So our x here, summation of x is 162. N is 6 because there are 6 scores. 1, 2, 3, 4, 5, 6. Okay, so we will substitute these values to the formula. So we have mean is equal to 162 over 6. Then our mean is 27. Now, in order to get the scores deviation, we will subtract the mean from the scores. For example, so we have 22 minus 27. So the answer is negative 5. Then on the third column, you will get the absolute value of the scores deviation. So if this is negative 5, it becomes positive 5 on the third column. So next is 24 minus 27. So we have negative 3. and it becomes positive 3. Then 26 minus 27, so we have negative 1. Then it becomes positive 1. Next is 28 minus 27, so it becomes positive 1, then positive 1. Then 30 minus 27, so we have positive 3, then positive 3 here. Then 32 minus 27, so we have positive 5, so positive 5. Okay, now we are going to get the sum of the absolute deviation. So the sum is 18. So the formula that we're going to use is MAD is equal to the summation of absolute value of x minus mean over n. So our value for this formula is 18. Our n is 6. Then substitute the given value to the formula. So we have 18 over 6. Then our mean absolute deviation is 3. So that is the answer. Let us now proceed to mean absolute deviation for group data. When the data are presented in a frequency distribution, the mean absolute deviation is computed in the following manner. Number 1, compare the mean of the distribution. Number 2, find the deviation of each class mark from the mean. Number 3, multiply each absolute value deviation by the corresponding class frequency. Number 4, divide the sum of the products in step 3 by the total number of observations to get the mean absolute deviation of MAD of the group data. So we have the following formula for mean absolute deviation for group data. So we have formula for sample and formula for population. But this time, we are going to use the formula for sample. So MAD, which stands for mean absolute deviation, MAD is equal to the summation of F times the absolute value of x minus mean over n. So F stands for frequency, X stands for class mark, X bar stands for sample mean, N stands for total frequency or sample size. While the formula for the population, MAD is equal to the summation of F times the absolute value of x minus mean over n. For example, find the mean absolute deviation of the heights of 50 students. The frequency distribution of whose height is given below. So these are the heights, or this is the class interval, the frequency, class mark, and fx. So before we proceed to the formula of getting the mean absolute deviation, let us first solve for the mean. So the formula for the mean for group data is different from ungrouped data. So we have already computed the fx, or the frequency, times the class mark. So we are going to get the total of fx. So the total of fx is 8,012. Now we will get the mean. So the formula for the mean is equal to the summation of fx over n. So our fx here will be replaced, or will be substitute to 8,012. Our n is 50. So it came from here. So substitute the given values to the formula. So we have 8,012 over 50. So we're going to divide. So the answer will be 160.24. Now we will get the absolute deviation. Okay. So the first row, we're going to subtract the mean to the class mark. So for example, so we have 154 minus 160.24. So the answer will be negative 6.24. But you have to get right away the absolute value of negative 6.24. So it becomes positive 6.24. Okay, next. So we have 157 minus 160.24. So the answer is negative 3.24. So get the absolute value, then it will become 3.24. Next, 160 minus 160.24. So the answer here is negative 0.24. Then get the absolute value, then 0.24. Next is 163 minus 160.24. So the answer here is positive 2.76. So since this is already positive, then we will just write it here. Positive 2.76. Next is 166 minus 160.24. So the answer is 5.76. So we will write 5.76. Now, for the last column, we are going to multiply the absolute deviation to the frequency. Okay? So, 3 times 6.24. So, the answer is 18.72. 10 times 3.24. The answer is 32.4. Okay, 21 times 0.24. The answer is 5.04. Then 12 times 2.76. The answer is 33.12. Next is 4 times 5.76. So the answer is 23.04. Okay, so we have completed the column. Ayan. So, the formula that we're going to use is MAD is equal to the summation of F times the absolute deviation over N. So, we are going to get the summation of F times absolute deviation, meaning we are going to add this up. The answer will be 112.32. Then, our N is 50. So, substitute the values to the formula. So, we have 112.32 over 50. So, we are going to divide. So, the answer will be 2.25. So, the unit is centimeter. So, this is how we solve the mean absolute deviation. Okay? So, thank you for watching.